Hey, what's up, guys? Hey, yeah, recently I come out with like some YouTube burnout, so I don't want to film the video. But now I think I still like want to make some video. So in this video, I want to talk about this problem. So this problem is like commonly shown in some interview. So the question is that okay, so this question is the following. Okay, so what is the upper bound? What is the upper bound? Right. So if you have a matrix which is n by n, and it's a complex coefficient or real coefficient, and then what's the upper bound of the rank of A if you know A to the K is 0. Okay, so the question is that if you know A to the K is 0, that what's the upper bound? So obviously K should be greater or equal to 2, right? I mean if K is 1, then A is 0, so rank will be 0. Okay. So the proof, okay, so let me just tell you the answer. Okay, so the answer, the simple answer that one can obviously derive is using the previous video. I have a previous video introduced so-called the Sylvester inequality. Okay, but okay, but another proof, yeah. So that's one can using the Sylvester inequality. Okay, let's see. So I think previously I make a video talk about the Sylvester inequality. Okay, so the simple version, which is two equivalent version. One is the obvious way is that kernel AB, the rank of kernel A, the kernel AB. So the dimension, right? Dimension of kernel AB is the less than dimension A. So kernel A plus dimension of kernel B. Okay, and yeah, so this is the first one. And the second one is basically the rank AB plus n greater or equal to rank A plus rank B. Okay, so that's using I think in previous video that you can show these two are equivalent by just using the rank A. It's basically the dimension of the image A, and the image A dimension of image A is using the nullity theorem become n minus the dimension of the kernel A. Okay, so we can prove these two are equivalent to each other. Okay, so let's consider a simple case that K equals to 2. So we have rank A plus rank B is equal to n plus rank AB. Okay, so obviously I choose B equals to A, so the answer will be rank A plus rank A, that's equal to n plus rank A squared, which is 0, n, because A squared is 0. So rank A at most n divided by 2. Okay. So obviously that this answer I should write as this, right? I should write that if I should write the floor, because if n is squared, n is even, then divided by 2. If n is odd, then there's nothing I need to, then I need to minus 1. Okay. Maybe let me just close this stupid video. Okay. Okay, so now let's work for general K. Okay, so for general K, let's assume K to K0, and we need to generalize this. Okay, so let's write down a simple generalization, right? So we know that rank A plus rank B, right, is less or equal to n plus rank AB. Okay, so in order to do this, then I can replace this. Say I replace B to be like B times C. Then I will get rank A plus rank BC is equal to n plus rank ABC. Okay, and then I can do the same thing, right? I can just use rank B plus rank C less or equal to n plus rank rank BC. Okay, so this tell me something, right? This tell me that I can replace rank BC to be less or equal to, I can write rank BC greater or equal to rank B plus rank C minus N. Okay, I can plug in it. Okay, so I get rank A plus rank B plus rank C less N less or equal to N plus rank ABC. Okay, so I can shift this N to this part. Okay, so more generally, we can get the following. We can get the rank AI summation I from 1 to N that's equal to, that's not using N because there's N here, that's using M. Okay, so we got the minus 1 N plus rank product of I from 1 to M. Okay, so now we can solve the general question. So let's consider A to the K 0. So our equation tells us that we can sum of rank A, right? So we just choose M to be K, because then A to the K is 0. So we get the summation K I from 1 to K and A, where rank is less or equal to K minus 1 N, right? So this gives us the rank A is less or equal to K minus 1 divided by N K. Okay, so the answer, the general solution answer will be just this. Okay, so yeah, this is the solution. So this is like the mathematically that we solve this solution, right? So our answer will be just K minus 1 divided by K, choose floor, and yes, there's N here. Okay, so it's, yeah, so this is the answer. Okay, so now this problem is not yet finished, right? We need to talk about a construction. Okay, construction is that we need to construct such answer, right? We need to construct such answer. Okay, so this one is this problem is a little bit tricky. So let's go to a simple case. Let's say K equals to A squared 0, and then let's consider N is 2. Okay, so what's the natural solution that and then we know that rank A is bounded by 1. Okay, so what's the answer that I can construct? So I can construct A to be 0, 0, 0, 0, 1. Okay, if you know the quantum mechanics, this guy is just the spin operator, so it's S plus. Okay, if you know quantum mechanics, the quantum mechanics tell you S plus square is 0, so this is natural. And so it's also the rank of A is 1, right? So it's saturated is bound. Perfect. And how about A 3, 0? Okay, so rank A is 1, right? So I can do the same thing. I can get 0, 0, 0, 1 here, 0, 0, 0, 0, 0, 0. Okay, and you can check this is true. Okay. Oh, sorry, A squared 0 and consider N equals to 3. Okay, so it's fine. Okay, how about A squared equals 0 and N equals to 4? So rank A is less or equal to 2. Okay, so what should I do? I can get the block matrices, right? So this is the simple. So I can use the block matrices. I can just using this. Okay, so yeah, so block matrices, then rank A is 2. Okay, so this tell you the general construction. Because if A to the even, if A squared is 0 and N is even, then the rank A is bounded by N divided by 2. Then I can denote D1 to be the 0, 1, 0, 0. So the answer of A, well, can be D1, D1, D. Okay. So total is n even. And obviously you can check a squared is be d1 squared, d1 squared, d1 squared. Then by definition, your d1 squared is 0. Okay, so a squared is 0. Okay, and if n is odd, then you just do the same thing, but you add the small one here. Or I mean, you just use the same thing and replace all these to be 0. You just add a 0 here. Okay, so you'll be fine. Okay, I mean it's the same, or I mean it's the same as you can or sorry, maybe you should yeah, maybe you should, yeah, I mean you can place 0 here. I mean it's fine. Okay, so I think it's fine, right? You can construct, for example, n equals to 3, you can just do this. Yeah, I think these guys square 0. Let's check. Yeah, it's 0. Okay. So for the odd case, that you can just, your answer will be a to be d1, 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 1. Sorry, 0. Okay, the d1. Okay, so this is the construction. Okay, so now let's work on the general a to the k equals to 0 case. Okay, so this one you may need to think a little bit to construct such solution, but let me just tell you the answer. Okay, so it's not difficult. Yeah, basically you need to ask what's the natural solution of a to the cube is 0. Okay, so the fundamental solution should be 3 by 3, and you can check it should be here, should be this one. Okay, so this is called D, and then you can check that D, the rank of D is 2, and the D cube is 0. Okay, and so if a to the cube is 0, the answer will be n times 1, right? This looks like this. Okay. So when n equals to 3, that you should get 2. Okay, it's the same as this. So this is just for this answer. Okay, so in general A, that you can just construct for example, for k equal to 3 case, you can construct this D, D, D. Okay. Okay. And then you can put remaining here. And yeah, so all these have size k, all have size 3, size 3, size 3. And then the size for E is just the n mod 3. And n will be sorry, and this E will be the similar thing, right? You can check this. Basically you need to do these things, right? So D looks like the same, D is like something 0 and 1 here and 1 here. All these are 0. Okay, so this is the general story. So in general, I can define D to be 0, 1, 0, 0, 1, 0, 0, up to 0, 1 here, and then this is size is k by k. Okay, so this is the fundamental solution. So basically, you can check that d to the k 0, and the rank D is k minus 1. Okay, and you can define E matrices, which is 0, 0, and the same 1, 1, but with size n mod k. Okay, and A to the k 0, the maximum solution will be a block, right? Just D, 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 E. And then you can check the A to the k 0 because each small block is 0, and the E is just the remainder. Okay, so this is the solution for this stupid problem. So what's the upper bound of rank A of n if A to the k is 0? Okay, so see you guys next videos.